Classical mechanics, to study the motion of a system, we have different coordinate systems. Cartesian coordinate system, spherical coordinate system, cylindrical coordinate system, plane polar coordinate system we are having. So, we have discussed about the Cartesian coordinate system, that is in the Cartesian we have x, y and z as the three coordinates, and that is very simple to be discussed. Now in the spherical coordinate system, our coordinates are what? That is r, theta and phi. You can see here r, theta and phi. These are the three coordinates in the spherical coordinate system. Now in the spherical coordinate system, r is known as the position vector, theta is known as the zenith angle or the polar angle, and the phi is known as the azimuthal angle or the longitudinal angle. Now r has the range from 0 to infinity. It means r can take value from 0 to infinity. Theta can take value from 0 to pi and phi can take value from 0 to 2 pi. This is very important. Okay. You should remember the range. Now, how this range is decided? Now, let us study the diagram of the spherical coordinate system. Now, in the spherical coordinate system, you have, let us say, this point P. You have this point P, and this point P is at the distance r vector. This r vector is the radial distance. This r vector is nothing but the radial distance of this point P. This point P is at the r vector from the origin. And let us draw the projection of this P point. दिस रेडियल वेक्टर की हमने क्या की है, प्रोजेक्शन ड्रॉ की है एक्स वाई प्लेन के ऊपर. दिस इज योर एक्स वाई प्लेन एंड वी हैव ड्रॉ द प्रोजेक्शन ऑफ दिस रेडियल वेक्टर ओपी एंड नेम द प्रोजेक्शन एज ओ एन. ये जो आपकी ओ एन है, ये आपका प्रोजेक्शन वेक्टर है ऑफ दिस रेडियल वेक्टर ओपी, राइट. एंड नाउ let us decide what is r, what is theta and what is phi. ये जो position vector है origin से, this is nothing but the r vector, that is the radial distance. Now what is the angle theta and what is the angle phi? Theta is the angle which this radial distance OP vector makes with the z-axis. Z-axis के साथ जो ये आपका radial vector OP vector angle बनाता है उसको क्या बोलते हैं, theta vector, and this direction is of theta cap, right? Now what is phi cap? You can see this is the projection vector of this vector. Now this projection vector ON vector makes an angle with the x-axis and that angle is known as the phi cap. इस angle को हम क्या बोलते हैं, phi cap angle बोलते हैं. Now this phi angle can range from 0 to 2 pi, but this theta can range from 0 to pi only. क्योंकि ये यहाँ जा सकता है, यहाँ जा सकता है. Only this can take from 0 to pi values, but this phi can take from 0 to 360, that is 0 to 2 pi values. So you should remember r cap is the unit vector in the increasing direction of the radial distance. You can write r vector as xi cap plus yj cap plus zk cap, where theta is the angle which the radial vector makes with the z-axis and theta cap is in the direction of the zenith angle. Phi is the angle that the projection ON makes with the x-axis. सबको clear what is r, what is theta and what is phi and what is their ranges? यहाँ तक सबको clear है. Now let us study the relation between the Cartesian coordinates and the spherical coordinate system. So first of all you should remember that in the spherical coordinate system, r cap, theta cap and the phi cap are mutually perpendicular to each other. They are mutually perpendicular to each other. Like in the Cartesian coordinates, x, y and z are mutually perpendicular. Here also they are mutually perpendicular to each other. And the relation between the Cartesian and spherical is x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. Right? You can easily see from here, this is r vector, so this is z vector. So this is angle theta, so z is equal to r cos theta. Very simple. Now this x is equal to this rho cos phi, right? And this rho is nothing but rho is r sin theta. Rho is nothing but r sin theta. So x is r sin theta cos phi. Similarly, this y is rho cos phi, rho sin phi. So y is equal to r sin theta sin phi. Z is equal to r cos theta. Very easily you can do this. Now Now you have to remember the relation. So r vector can be written as r sin theta cos phi I cap, r sin theta sin phi j cap, and r cos theta k cap. So this is the way you can write the r vector. And since they are perpendicular to each other, so r cap dot theta cap is equal to 0, r cap dot phi cap 0, and theta dot phi is 0 because they are mutually perpendicular. So their dot product will be 0. Okay, and cross product will give you the vector like r cap dot theta cap will give you phi cap, r cap dot phi cap will give you minus theta cap, theta cap cross phi cap will give you r cap. क्योंकि ये म्यूचुअली परपेंडिकुलर है, क्रॉस प्रोडक्ट दो वेक्टर्स की आपको वो वेक्टर देती है जो पिछले दो वेक्टर्स के परपेंडिकुलर होता है, तो डॉट प्रोडक्ट 0, क्रॉस प्रोडक्ट will give you the vector that is perpendicular to both the vectors like this. And if you reverse the cycle, r के बाद theta के बाद phi के बाद r, यहाँ पे मैंने r phi तो minus theta, r phi minus theta, very easy. Okay, so you can try the numericals on the spherical coordinate system. This is the numerical one in which the spherical coordinates are given and you have to find the Cartesian coordinates. So just use these formulas, put the values of r, theta and phi and easily get the value of x, y and z. You can take a screenshot or note down on your notebook. Now in the next numerical, you have to convert the Cartesian into spherical. So you have given the Cartesian coordinates x, y and z. You have to calculate the spherical. So in spherical, first of all, you will calculate r, that is r is equal to under root of x square plus y square plus z square and you get the value. Now to calculate theta, put it in the z is equal to r cos theta. Okay. So put the value of r, you have calculated, put the value of z that is given and calculate the theta. And then put the value of r and theta in any of these two and easily you can calculate phi. So just take a screenshot of this also or you can also note on your notebook. Clear with the concept of spherical polar coordinate system, everyone?